Figure 430A, the meter bridge. At balance point C, there is no deflection. The sensitivity galvanometer G, if L1 is equal to length AC and L2 is equal to length BC, we have that S over R is equals to L1 over R L2, or S over R is equals to L over 100 minus L. Example 3. When a known standard resistance of 2.0 ohm is connected to the 0.0 cm end of the meter bridge, the balance point is found to be at 55.0 cm. What is the value of the unknown resistor? Solution. At balance point, L1 over L2 is equal to R1 over R2, but L1 is equal to 55.0 cm. L2 is equal to, in bracket, 200 minus 55, which is equal to 45 cm. R1 is 2.0 ohms and R2 is unknown. 35 over 45 is equal to 200 over R2. Therefore, R2 is equal to 2 times 45 all over 35, which is equal to 2.57 ohms. Example 4. Looking at figure 430B, in an meter bridge arrangement, there is a zero deflection of galvanometer when the L1 is equal to 40 cm, as shown in figure 430B. Above, calculate the value of the resistance R. Solution. At zero deflection of galvanometer, L1 over L2 is equal to 10 over R. 40 all over 100 minus 40 is equal to 10 over capital R. 40 over 60 is equal to 10 over capital R. Therefore, R is equal to 10 times 60 over 40, which equals to 15 ohms. Electrical conduction through liquid. Electrolysis. Electrolysis is the process of decomposing electrolytes into their component ion by passage of electricity through them. Faraday's law of electrolysis. First law. The mass m of an element deposited in a given voltmeter is proportional to the current I and the time t, or the quantity of charge Q flowing. Thus, M is proportional to Q, M is proportional to IT, M is equal to ZIT, where Z is a constant of proportionality known as electrochemical equivalent, which is the mass of the substance deposited by 1 coulomb of electricity. Z is equal to mass over IT. Faraday's second law of electrolysis. Second law. For a given current and time, the mass of element deposited in electrolysis is proportional to its chemical equivalent, or to its relative atomic mass over variance. Thus, mass of copper deposited over mass of silver deposited equals to chemical equivalent of copper over chemical equivalent of silver. Example 1. In an electrolysis experiment, cathode of mass 5 gram is found to weigh 5.01 gram after current of 5 amp flow for 50 seconds. What is the electrochemical equivalent of the deposit substance? Solution. Mass of substance deposited equals to 5.01 minus 5, which is equal to 0.01 gram. Current supplied equals to 5 amp. Time for which current flowed equals to 50 seconds. From M equal to ZIT, where Z is electrochemical equivalent. Substituting for the above equation, we have that Z is equal to 0.1 all over 5 times 50, which is equal to 0.0004 gram per coulomb. Example 2. In copper plating, a current of 0.5 amp is allowed for a cathode area of 100 cm cube. If this current is maintained constant for 10 minutes, calculate the thickness of the copper deposited. The electrochemical equivalent of copper is equal to 0.0033 gram per coulomb. Density of copper is equal to 10 raised to power 4 gram per cm cube. Solution. Mass m of copper deposited is equal to ZIT. M is equal to ZIT. Mass is equal to 0.0033 times 0.5 times 10 100 times 60 equals to 0.99 gram. Volume is equal to mass over density, which is equal to 0.99 gram over 10 raised to power 4, which is equal to 9.9 times 10 raised to power minus 5 per cm cube. But thickness is equal to volume over area, which is equal to 9.9 times 10 raised to power minus 5 all over 10 raised to power 2, which is equal to 9.9 times 10 raised to power minus 7 cm, or 10 raised to power minus 6 cm approximately. Example 3. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36.0 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5.0 minutes, calculate the current. Solution. Electrochemical equivalent of silver is equal to 0.0012 gram per coulomb. Mass of silver to be deposited is equal to 36.0 gram. Time taken for the passage of current is equal to 5 minutes. From M equals to ZIT, therefore I is equal to M over ZT, which is equal to 36 over 0.0012 times 5 times 60, which is equal to 100 amp. Example 4. Calculate the mass of oxygen liberated at the anode during electrolysis if 4 grams of copper is deposited at the cathode. Chemical equivalent: oxygen is equal to 8, copper is equal to 31.5. Solution. Mass of oxygen over mass of copper equals to chemical equivalent of oxygen over chemical equivalent of copper. Mass of oxygen over 4 is equal to 8 over 31.5. Mass of oxygen is equal to 8 times 4 all over 31.5, which is equal to 1.02 gram approximately. Magnetic field. Earth magnetic field. The Earth acts like a magnet. The north geographical pole has south magnetic polarity. Since it attracts the north magnetic polarity, the south geographic pole has north magnetic polarity. Angle of declination or variation. Map are marked with true north, while a compass used to find direction will give magnetic north. The correct angle of inclination marked on the map has to be added or subtracted.